Developed for the Cognitive Robotics class at UC Irvine, Clarence is an autonomous dancing robot. He is derived from the LEGO NXT robot kit and is designed to entertain you. In this video, his morphological design, strategy for implementation, and overall performance will be discussed. As you can see, his morphology resembles animals, with overall symmetry, 2 front legs, and a head situated in the superior aspect of his body. Clarence's head moves to the beat of a song. His neck and head appendage were constructed from a motor, a spring, and a foam sphere. The spring allowed the lightweight foam head to bounce and exaggerate the motorized head movement. This morphology enabled a fun, seemingly excited head bopping that moved to the syncopated beat. We used motor encoders to control the head movement, which allowed a controlled, restricted range of movement. We considered human aspects of neck movement, and we wanted him to resemble that system, since our heads are limited in a range of movement, but the motors are oriented by rotation. We only had to rely on coding to do this and limited controlled movement. We did this by using the motor encoder commands. The motor encoder tells the brick that the motor is rotated so many degrees. This is comparable to our sensory system telling us when we're flexing our muscles too far. His legs were motorized and controlled by afferent signals from the light sensor input. The design of his legs were built so that he would stand upright and execute both a kicking motion and a walking motion. His legs were stabilized by Lego pieces, and a circular Lego bit to make contact with the floor and also to resemble a morphological foot. They were offset to induce reciprocal motion, or bipedal motion, and placed parallel to resemble kicks. His leg motor speed corresponds to the intensity of the light. The arms were attached to the brick by Lego pieces, and small springs were attached to the end of the Lego piece with duct tape. Note, there was no motor or neural control of the hands. The springs caused a lively motion that was dependent on the robot moving about. This experiment showed us that intelligent agents can exhibit interesting behavior from very simple coding. Having motors directly controlled by sensors in this fashion produces intelligent behavior. This claim about intelligence requires the assumption that intelligence can be identified by observation of behavior, or that intelligence emerges from a body acting in its environment. Additionally, we found that simple coding can result in dynamic behavior when implemented in the Robot C programming language.